Thank you so much for coming, everybody. Welcome to today's event. You made it in the snow. You're all so brave. We've got a great day lined up today, and we're going to get started. So this is Flower City AI. I am Max Irwin, and I've been in the business for a while, and I've been working on really complex problems in software and technology and data for a long time. And I have a business called Max.io that I started a couple of years ago. And I did so in Rochester, and I started to meet a lot of people and coming to meetups and seeing all kinds of interesting things happen in our city. And you know, this is the rundown of my resume, but more importantly, I'm the organizer of today's event. So why are we here today? Why did I do this? A lot of people ask me, why are you having an all-day AI conference in Rochester? Was the question I got most often when I first started thinking about this back in May and June. And because something's happening, I think it's pretty obvious. There's a lot of stuff going on. Everybody's a little bit nervous. Everybody's a little bit excited. But we haven't really seen this type of shift since maybe the internet or smartphones coming out. So really, really important, significant things are happening that are starting to change our lives. And we're all part of it. It's going to impact pretty much everybody. So I wanted to get people together to talk about this, to form a community, and to go forward and see what we can do together, see what we can do in Rochester or in Buffalo or any other place in Western New York, because we have the talent and we have the technology and we have the connectivity and all these things that we need to be able to do the things that we want with this. But if you'll indulge me for a moment, I'm just gonna set things up. This is a keynote after all, so I got to warm up everybody else's talk. So I want to talk a little bit about what AI is and how we got here. So when I say AI to people who aren't familiar with it or maybe tangentially familiar with it, think about this complex thing like a neural network or maybe some phrase or term that they heard. So, maybe you have some image of like some mysterious organic thing that you might see in your head. So this is a graph core visualization of ResNet 50, which is a convolutional neural network. So people might think about this like advanced technology that's really, really hard to understand, right? And they can't really picture it and they don't really know what it is. A lot of people might think of, well, it's ChatGPT or it's Midjourney or something like that. But it's actually much simpler than that. And I think a lot of people, they don't fully grasp just how simple artificial intelligence is as a concept. And all it is a machine's interpretation of data or knowledge. And that's what AI is. So it takes many shapes and sizes and forms. And we see this happening everywhere. If you're writing software, you do a lot of manual data pipelining and work and stuff like that to get stuff into databases and to, fill out forms and stuff like that. But that's pipes. Interpretation is different. Interpretation is letting a machine, a coded machine, look at the data, maybe with some instructions and objective, and figure it out on its own, over a certain amount of time and with a lot of parameters. Those who work in AI, know that this is maybe a drastic oversimplification, but I think this is really the heart of the matter. It's just machines thinking about data in their own way, the way we tell it to. And you need a couple things to make this happen. So it's really the intersection of knowledge, computing capability, and mathematics. So I'm going to take you on a brief little history of all three of these things and how they intersect to bring us here. So back in 4,000 years ago, we had maybe the first library. I don't think people really know for sure. It's a long time ago, but this is a cuneiform tablet that they found in a library that was probably, sometimes around 2600 BC. And they found a collection of items that people could go and read knowledge in a written language in a central location. Now we skip forward a couple thousand years, and libraries are mainstream. They're accessible to people in a community. There's more knowledge on maybe scrolls and tablets and parchment, and people can go and they can read and they can learn together. But it was still pretty manual, and it was really hard to find new knowledge. So in the 1500s, something really interesting happened. The index was created. So the index, as you all know, is you look at the back of a book and you want to find a concept that you're interested in. So you don't have to read the whole book, right? You can just find the information that you need. And you can go right to that piece, and then you can flip to the page and read the little bit that you're interested in. This is really helpful when you have an encyclopedia that's 1,000 pages, right? So this is really, really helpful. But not everybody has access to a library, right? Especially, before trains, it was hard to get places. And if you lived in a rural area or you were nomadic, you didn't have access to any of this stuff. And beyond that, a library only has a very tiny fraction of knowledge. It doesn't have the world's knowledge. You hear myths and stories about the Library of Alexandria that housed all of human knowledge at the time that was destroyed, and we've lost it. But not everybody can get there. That's a faraway land that you might not have access to. So learning is very restricted. So we needed a way to transmit information. So a very, I'll say, curated timeline that I'll just shout out. So first we got the telegraph, where you can transmit text over wire. Then we got film, so you could film visual and audio, and well, not audio at the time, but then you can send it elsewhere, and then you can see moving images from a place that didn't originate. Then you've got radio, and you can transmit audio signals, and then television, and you can now transmit data, visual data and audio data. And then we had a bit of a gap, a bunch of things were happening. I left out some important things, of course. I left out like the Gutenberg press and the telephone, and there's a whole bunch of other technologies. But, skip ahead, we got the internet, and then really the first amazing application of the internet for most people was email, because this is now the ability to type text and send it over to another person, and now you have a digital representation of that text that's been transmitted and accessible from another place. Then in 1989, we got the web, where you could go and browse knowledge that other people have written down and put on the internet, and you could click links and just do what you do. In 1996, something really, really important happened, and that's actually a really pivotal moment for my career, because in 1996, we got the first web search. So I don't know if anybody else was around using computers at the time, but this is the same year that I started university. And I went to the computer lab for some of my courses, and this is actually the search engine that I used. It was called InfoSeek. And this is an old Netscape Navigator 1.0 browser. It looks pretty pixelated, and things have changed quite a bit. But now I can go, and I don't have to click on a web page. I can actually search, and it will search. It indexes knowledge from the web. So this is the index that we talked about, that was invented in the 1500s, the same thing. But now it's all of this digital knowledge that's been processed and put into a centralized index, and anybody can search it and find the information that they need. But still, indices are human organized, and you think, well, the computer's processing it and stuff like that, but really it's following the same structure that we know. It finds concepts in text and it puts them into a data structure, and then that data structure is accessible and you can look it up. And humans had to do spend a lot of time tweaking things and getting things right, so that when you actually searched for a term, the right term came up. And people weren't always so kind. They always tried to get their page to the top of the search results list. So a lot of people still do this. It's gotten a lot better. But if I wanted to have my website show it for the word cars. If I'm selling cars, I just put the word cars in my document, 1,000 times at the bottom, and it says cars the most, so it comes up to the top of the page. And things have changed quite a bit, but this is still like humans working against humans, like tweaking, the algorithm versus their content and trying to get things to work in the way they wanted. But beyond indices now, we have exabytes of data all over the world. And this is a map from 2002. This is published on BMZ Digital. And this is a really interesting picture of just how much text and video and audio and sensory information there is. These are all the cloud data centers that are available in the world. It's just incredible how much data that's available. A lot of the AI that you see these days uses only a small portion of this to train their models. There's no model that has all of the world's data, all the exabytes. But this just goes to show what's available in the world today. So that's knowledge. Now we need compute. We need to be able to read the knowledge. And how do we do that? So if you think about GPT 3.5, it was trained on 100 billion words. I actually did the math, and it would take me 800 years to read 100 billion words. OpenAI made sure that they had enough compute power to read those 100 billion words in less than a year on a vast amount of compute. So when you have something of this scale and power, it's incredible. It's incredible to take, a good portion of the world's human knowledge and text and to be able to consume it and learn it and train a model in a year in the equivalent of 800 human years. So how did we get here? Apologies for the small font, but we have, we started off with CPUs a long time ago. I'm not going to go into the whole history of computing, but really what makes modern AI possible are GPUs. Specifically, we started with graphics processors in 1996, and this is for processing visuals, being able to play games and do 3D modeling and things like that. In 1999, things got a little bit more advanced. We got things like shaders and the ability to display really complex information very quickly in 3D. And then in 2006, something really interesting happened. A couple teams realized that they could use GPUs and change the architecture a little bit and create software stacks so that you can use them beyond graphics and to do general purpose graphics processing. So this means a lot of linear algebra. This means a lot of parallel processing using the cores that are available in a GPU, because it was a very natural progression of the technology. And then about 10 years later, we got another significant change. We got something called the tensor core, and a tensor core has very specific operations and capabilities to take a very large tensor or a matrix and do operations on it with other tensors and matrices. So this really accelerated the ability for computation. And then in 2018, we got the B float, and the B float is the brain floating point, which is a more flexible data type that is more amenable to fast processing of the types of operations that we need for artificial intelligence. So if we look at like the NVIDIA V100, this is released in 2017. We have, a 640 tensor core GPU. This is a very specific purpose compared to a CPU that, at the time, most people had 4 or 8 core CPUs on their desktop or in the cloud. So you can see the scale and the ability to really utilize the amount of compute that is vastly different from a CPU. And the other thing you need is RAM. So this is the progression of not just CPU cores, but of RAM that you require. So the A100 is at the top of the list now. Now we have the H100 as well, and there are newer processors coming out and more specific general processors for specific operations. But the amount of memory that you need to process, 100 billion words over months, it requires a lot of memory and memory bandwidth, and also the compute to go with it. So now we have, this is just one card representation, but imagine if you had a whole data center of these cards and how many cores you have, millions of processing cores and petabytes of RAM to handle this. So that's compute. And we just briefly go into mathematics. So math, we had calculus in 1670, Bayes rule in 1763, linear regression in 1805. Then we had maximum likelihood estimation and variance in the early 1900s. Stochastic gradient descent is in the 1950s. The first neural network, the perceptron, was a feed-forward neural network and a perceptron in the 1950s and 60s. And then we got a lot of optimizations and nonlinearity to handle how, to make sure the model doesn't collapse on itself. Then we got backpropagation. Hinton et al. Worked on backpropagation in 1986. And then we got deep learning in 2012. And deep learning is coincided with what a lot of the recent developments in GPUs enabled. And then in 2018, we got the transformer. And I'm going to talk about the transformer for a moment, but before I do that, this is the intersection that we're at, right? Believe it or not, it's almost 2024. Can you believe it? 2023 is almost over. And we've got compute, knowledge, and mathematics all coming in on their separate timelines and converging on the present. And, all of us in this room, we've seen a very, very small history of this in our lifetimes, but there's just so much that has happened in terms of people working together on different problems to try to solve things very specific to what they were working on at the time. But it just so happened that all of these things came together to make artificial intelligence possible now. So some of the things that I'm working on using this technology, transformer embedding. So jumping back a little bit, I talked about human organized knowledge. I talked about the index, the inverted index, and how people organize knowledge. Transformer embeddings actually enable machine organized knowledge. So this is the ability for a machine to read vast amounts of information and organize it itself. And the technology that made that possible is the transformer, which is a type of neural net architecture. And it can take all this data and it can read all the data. And then at the end of the training, it has a representation of the knowledge that it learned. And now you can give it input and it'll give you a numerical representation of the knowledge. And we call that an embedding. And then embeddings can be compared to one another. So I can have a paragraph and I can relate it to another paragraph. So it's not just a concept looking up for a source in a book. Now it's actually relating the real fruit of knowledge, the juice of knowledge, to other pieces of knowledge in this vector space and be able to relate things to one another and really pull things together. The transformer also enabled the generative transformer. So this is what people think of when they, GPT is a generative transformer, generative pre-trained transformer. And BERT and GPT made use of the attention mechanism. The attention mechanism enabled specifically a neural net to look at an entire input stream in one context and to relate all of the tokens in the input stream to each other and to really be able to process all of this. Before it was just sequential. You had sequential reading of word to word, but now the word at the end of the sentence is also related to the word at the start of the sentence. And the attention mechanism enabled that. And that was really the crux of the ability of the transformer. So that's how this all came about. So when you combine machine organized knowledge with generative AI, you can do something really interesting. You can create a virtual research assistant. So if I have a huge document that's a PDF, well, I don't want to read the entire PDF all the time if I have a question. I mean, maybe there's an index in the back and I still have to flip it through and figure it out and then read it and then process it and understand it and then translate it to myself in my brain. But now I can ask a document a question. And I can say, well, if I have a lease, what are my maintenance requirements as a tenant? What do I have to do? And then an AI can read the document, find the required information that supplies the knowledge. It reads the whole thing and it says, well, here's the maintenance section. Here's some bit about insurance. Here's some stuff about, maybe shoveling the sidewalk, things like that. And then it processes it through generative AI and it prints out a summary. And not only does it print out a summary, but it tells me exactly where it got the information in the document. So this is a really, really powerful application of artificial intelligence. And this is what I personally work on. And I work with teams to build AI so they can find the knowledge that they need. And that's what I do at max.io. I also spend a good deal of time educating the public about AI. I've been speaking at libraries recently. I was working with teachers to help teachers understand how to use AI for good in the classroom and how to make sure they understand it and understanding AI literacy. And adult education and education of people who aren't technical and who don't understand all of these complicated things, to be able to understand how it works and why it works and what it does. And Flower City AI is an extension of that. So we're here to see how AI can be used for good and how it's improving lives in Rochester and in Buffalo and elsewhere. So some of the things that we're going to talk about today. So things that when I was growing up, I used to think of them as science fiction, as I'm sure a lot of us did. But now these things are reality. So as I just said, working with your own automated research assistant, having discussions with customizable virtual people, imagining your childhood dreams and seeing them come to life, equalizing the creative landscape with technology, finding long-sought answers to medical problems, getting help with navigating a costly bureaucratic process, making advanced technology accessible to everyone, doing so with forethought and accountability. And this is possible because the people who are speaking here today. So welcome to Flower City AI. This is the agenda. Please take a look at the agenda. Meet your fellow attendees and your fellow speakers. Engage with everybody. Pay attention. It's going to be really, really amazing. So with that, I'd like to welcome to the stage Evan Dawson, who's going to be our MC today. And MC is going to introduce all the speakers, and he's going to keep things moving. I'm going to be behind the scenes. If you want to ask a question or talk to me, I'll be around and available to help out if you have any questions. And Evan, he works with WXXI. He's the host of Connections, which is a midday talk show on NPR radio. And he's really incredible. I met him a couple of years ago because he was asking folks on Twitter what they thought of Web3. And I guess I was the first person to shout out my skepticism on Web3. This is, I believe, 2022, a year and a half ago. And he invited me onto the show. And I've been on several times now talking about technology. First, it started Web3 and then crypto and then moving into AI, because I said I don't want to talk about crypto anymore. I wanted to talk about AI because that's what I do. So he was kind enough to indulge me and bring me on as a guest. And I'm really happy to have him here now as my guest to take over the show. Thank you so much, everybody.
Well done. I'll make a few remarks here. I don't know if we need to grab a second microphone. I don't know if that can be usable. Let's see if we can. So a couple of weeks ago, I got in a little bit of trouble because I sent a text. And if you've ever are texting very quickly and you fire something off, sometimes you go back and read what you sent later and you find it really remarkable what your device thought you were trying to say. And what I sent to my boss was something pornographic. This is my boss. And I sent a quick response. Now, I shouldn't do this when I'm in a car. I was driving. But I was amazed that this is what my phone thought I was trying to say. And I thought, this device I've had it for a year. It knows my rhythms. And I made the conclusion that machine learning isn't as smart as I think it is. And that gave me some comfort that we're not yet going to be overrun by it. However, everything else around me, I'm amazed on a daily basis of what my device as a layperson. I'm with an audience of people who are essentially experts in your fields, and I'm blown away daily by it. So I find myself wanting to talk to people like Max and probably people like you, and you're probably going to have me harassing you to come on the show, maybe as soon as tomorrow, to kind of recapping an event like this, because I think the lay public, more than any subject I can think of, is really struggling to keep up. When Max showed us the convergence of not only knowledge, math, learning, but also the curve that we saw. This is happening at a pace that the general public is really going to struggle to know what it is that you're all doing. And I think this is a great chance for us to learn more today. It's really, really exciting just to kind of be in the audience and to be listening. And as much as I'm sort of occasionally a curmudgeon or a skeptic, I'm also a realist. And I'm really grateful that folks like you and folks like Max are leading us into this kind of a future. And I have a few questions for Max before we get to our next speaker. So I want to start. Is the mic working? Can you see it? Is it working? It is. That's great. So I want to start by asking you, typically when I'm interviewing you, the audience is the lay public. Now the audience is experts. So I want to start by asking you, how annoyed are you and how annoyed do you think most of the people in this room are at the general media's lack of understanding about AI and the way we talk about AI?
I'm not annoyed at all because
You cannot offend me. You can say anything.
no, because I'm 45 years old now, and I started working with computers when I was 7 years old. I wrote my first computer program at Harris Hill Elementary School over in Penfield when I was 7 years old. And my entire life, I've been trying to get other people to understand what I'm talking about. Because, I speak in another language, I get it. I guess it's not frustrating to me because I empathize and I understand, well, I spend all my time on this and you don't spend any of your time on this. So people know what they know. And I think maybe that's why, not to toot my own horn, but I think I'm really good at explaining this technology.
You are, that's what, yeah, I think
really
you are.
patient, and I have an empathy of understanding that, not everybody gets it. So I'm happy to try to break it down and explain it to other people. So, and I do get annoyed when people ask me to fix their printer. I don't.
Yeah. But I think that there are various levels of cost to society when the general public is poorly educated on things. So as I'm trying to cut my habit of being a professional football fan, but I remain stubbornly devoted to my hometown Cleveland Browns. And I'm constantly amazed when I sit in a bar and watch a game on a Sunday, listening to people who spend tons of time thinking about the National Football League, and they don't know anything about how it works. They don't know anything about how play calling works or why teams are doing what they're doing. And this is what they purport to be fanatic about. So it drives me crazy, but that doesn't really have a cost. You can be an idiot fan, it doesn't really matter. If society doesn't understand AI, and what the general public is thinking is that within a year, the machines are going to do something apocalyptic, or we will all be out of a job, or there's no way to integrate AI in ways that are beneficial to the education sector, to workers, to knowledge acquisition, then there is a real possible cost. And that's why I asked if you're kind of annoyed, because a lot of the reporting, especially in the last year, it's blown up, but a lot of it is quite dark. I mean, is part of today a chance to see the light in it? Is that fair?
I hope so, yeah, because all of the speakers are going to talk about really important, interesting things, and things that are good. And it's a way, this is being recorded. We're going to record as much as we can. So it's not just this room that's going to see what's happening here, but hopefully others, if they want to see, they can come back and look. And then this isn't the first event either. There's going to be more stuff happening after this. This is like maybe an inception of things that are to come. But to go back, it's like I think about cars. When you think about sports, I think about cars because most people don't know how a car works.
Absolutely.
And they just drive. And then, bad things can happen on the road. You were stuck on Lake Ave for,
Yes,
you had to
coming down today.
Maybe if people understood their cars a little bit better, then, you would have been stuck in traffic and people wouldn't get hurt and killed in car accidents. So I definitely think that education of technology is extremely important, and understanding what it is and how it works and how to use it, and how not to use it is really, really important. So education is the only way to solve that problem.
When we looked at entering 2024, all the convergence of this knowledge to this moment that we're in now, you could go back a year, September, I think, 2022, ChatGPT came out somewhere around there.
October, I believe.
Okay, so it's been just over a year. How much change have you seen in the industry in a year?
Quite a bit. In my industry and in the knowledge worker industry, everybody's jumping on board and doing what they can to use the technology. It's not perfect, and there's a lot that needs to be done. But now a lot, when I was working on the technology in like 2019, I was kind of new. There were a lot of people working in the field, but it wasn't mainstream. Now it's mainstream. So it was kind of weird to be in this situation where I was working hard on problems that, I was trying to explain to people and they didn't really get it. And then all of a sudden now everybody wants in. So it's been overwhelming a little bit with that. But we still have a long way to go. It's been a year with ChatGPT, and now the way I see people, not just in business, but, friends and family, it's starting to replace Google as where they get knowledge, which is a little bit dangerous in my opinion, because
they're not the same thing.
It's not the same thing. It's a latent repository of knowledge. It's not the actual knowledge. So there's some things that we need to make sure that the public understands, and you shouldn't just replace Google with ChatGPT right away. You should still do web search and go find primary source knowledge. That's really important.
I have an 11-year-old son, and when the pandemic hit, he's 8 years old and he started writing a novel. I'm like, okay, well, that's ambitious. He's about 14,000 words in now. And he said to me last week, I could just have AI finish it, which is true. I don't think that would be a great use of his ability to interact with technology. But he also said to me recently, what do you think I'm going to do for a career? And I said, you're too young. You don't have to feel that pressure. You're 11 years old. He said, what about ethical AI? That's my 11-year-old said. Now, I don't know if he's heard it from me. He does not listen to the show, that's for sure. But he likes to read. And I thought that was really interesting. And I know there's going to be some discussion of that today. I know the media is sort of maybe focused on AI a little tilted in a way where a lot of it's on ethical AI. That's one where I think that's a fair thing to really be focused on in a lot of ways. Are you content that ethics and careful use of this kind of tech is at the forefront, or has it been sidelined?
I don't think it's sidelined. There are a lot of people who are still working on it. We're going to hear from Mark Weber today, and he's going to talk specifically about that. And I think that the more educated you are, then the more opportunity you have to do things the right way. So that's, again, I always go back to education. But when are you going to have your son on the show to talk about ethical AI?
Yeah. He also knows that I'm not a fan of the technical term is bullshitting. So I said, you have to really know what you're talking about, and be curious. This is the rule for Twitter, but it's also the rule for most social media in life. The world needs to listen more and talk less. So we'll see. And having said that, anything you want to kind of wrap up here before we bring on the next presentation?
Again, thanks for coming. Enjoy yourselves, and we're going to have a great time. Thank you.
Thank you, Max. So this will be kind of the rhythm, and I want to apologize in advance because what I don't want to do is waste your time by asking questions that would be obvious to all of you as the experts in the room, but are more interesting to me as the lay public. I'm going to do my best to listen and ask pertinent questions and follow up. And I think there will also be plenty of occasions when we do this that if you want to, through me when a speaker is done, follow up and ask questions before we move on to the next, let's do that. So we definitely can. I want to bring up Masoom Hassan, who is the co-founder of Senshin.io, a computer science PhD and entrepreneur. And Masoom's going to be talking about virtual human platforms, how this relates to education, skill development, yes, entertainment, but practical applications in society. This is, pretty much everything on this list today is very interesting to me, and Max done a great job setting it up. I'm really excited to hear from Masoom, and please welcome him now.
We got to switch out laptops, so this will only take a moment.